Oh, good morning and welcome to our final session this morning of our virtual conference. This morning I have a great pleasure to welcome Dr. Emma Taylor, who's provided clarity on the cybersecurity elements on the railway in previous presentations to us. And today we'll be looking at building confidence for both passenger and operators in the railway scenario. Dr. Emma Taylor is the head of digital safety at rail cyber security solutions firm RazorSecure. Emma is a chartered engineer and a fellow of the Institute of Mechanical Engineers and the past chair of the Safety and Reliability Society. Emma has over 25 years of experience across multiple sectors, including rail, oil, gas, and obviously the energy and space and highly regulated environments. As head of digital safety, Emma is responsible for setting and implementing the strategy to lead the integration of safety and cybersecurity for transport, rolling stock, detection, monitoring, and asset recovery, with a focus on digital incident investigation. Emma is also a professor at Cranfield University, a visiting professor, and mentors widely across sectors and generations, and received numerous awards, including the 2018 Telegraph's Top 50 Women Engineers of the Year, and this year's Computer Weekly Top 50 Most Influential Women in the UK Tech. I've certainly been influenced by Emma this year. I can't offer a prestigious award, but I am pleased to welcome Emma to our conference this year. Welcome, Emma.
So much, IOSH, for the opportunity to come and speak to your worldwide audience. I am very much looking forward to the opportunity to run through with you today my talk and to frame the conversation in terms of the railway, because we are here looking at coming back on track with the railway. This is the theme of the overall conference, and the railway is so important to the UK and to the economy worldwide. If we can't move people and goods, then we can't maximize the benefit of the railway. So my talk today is called Opening the Door to Performance, Maintenance and Safety. And of course, we are a rail cybersecurity solutions company, but I'm going to be putting cybersecurity in context: operations, performance and maintenance and safety, and of course the broader benefits of the railway for the economy and society. So let me see if it's going to let me do a second slide. Brilliant, perfect. So it's in 4 parts. I'm going to talk for somewhere between 25 to 30 minutes. I'm going to first of all give us a little step back on the digital railway in the broadest sense, because our railway is changing around us, and this does give us challenges, changes and benefits. Then I'm going to get straight down to some practical details, what we see in our day-to-day current activities around digital maintenance, around our clients and more broadly, and how that impacts their ability to do performance and safety. And of course, we are a highly regulated industry, so I'm going to feed in some management frameworks. And then last not least, some priorities and next steps. As in my last IOSH talk, which is also on the YouTube channel, I'm going to weaving in some proper information on cybersecurity, not filtered down, not watered down, but by putting it in context and talking through, I'm hoping that I can build everyone's confidence and level of understanding. So without further ado, switching to the first slide in the sequence. Who are we? We do what I call practical cybersecurity. We are a company funded by investors, and we have protected more than 50 million passenger journeys to date. And that in itself gives some very sort of practical frontline experience. Some of our clients are less open to having us discuss the fact that we work with them for obvious reasons because of cyber security. Others, you can see 2 UK operators there, Northern and West Mids, and we work with manufacturers as well. So this is not designed to be an advert, but more to say that often in cybersecurity talks, people talk in generalities or overview, and everything that I'm going to talk to you today is informed by our practical experience. Unsurprisingly, for any of you that's been on a train recently, and I hope more and more of you are having the opportunity to travel, trains are digital. Visibly, you can see passenger information displays. Visibly, you can see digital sort of improvements on track and off track. But perhaps what people don't realize is the amount of work that's being done under the bonnet. And even more mature rolling stock is being upgraded with passenger Wi-Fi and other systems. There is this ongoing digitalization, and this gives clearly direct benefits to passengers, but it also gives benefits to the overall economy. When you look about the benefits that rail freight have provided to moving goods in the UK, and I'm sure it's elsewhere the same, and the absolute volume of billion net tons per kilometre that shifted, it's quite extraordinary. So there is this overriding need to have good performance, obviously good safety, and good maintenance. These things all come together, and when you've got digital fleet, then digital maintenance becomes core. Now, when I first start these talks, I sort of say, let's broaden people's sort of mindset. What constitutes a digital train? What digital systems are there? Of course, we hear about moves to ETCS signaling. We can see that, like the sophisticated software operating brakes, the core safety systems have got software involved. But there's other things as well that you might not immediately think that are important in terms of safety, but are clearly important in terms of maintenance, whether it's like sort of networks and video and demand, whether it's like your passenger information, your HVAC. All of those need to be maintained, updated, patched, fit for purpose, and also them are important to the overall safety of the railway, because if you give passengers wrong information, or if you control the temperature too hot or too cold, clearly we have the possibility for knock-on effects. So we have digitalization at every level, and also maintenance of those digital systems is key for the overall performance of the railway and safe running. Maintenance is at the heart of it all. Now, the previous picture and the one I've just shown you are from a new technical specification 50701, which has been released by Senelec this summer. And I would highly recommend, if you're not going to read any other technical specification or standard of the year, to pick this up, because it's called Rail Cybersecurity, and it's written in a way to be accessible. And one of the most powerful messages that it opens with, that's encoded in this picture, is that everything is connected at a digital level. You wouldn't normally think that, like, track is physically connected to operations control and maintenance. There is one object and another object, and they're not linked. But at a digital level, when you consider information flow, then they are. And you can see here that irrespective of whether you're looking at signaling, which is red, command and control, which is orange, auxiliary systems, green, comfort or public, there is some form of data flow, some form of public network or private network. And the little sort of boxes there, like brick walls, are like firewall, gateway or router, because this information can't flow freely. It needs to be managed and controlled as it is moved around the network. And you need to make sure the information is what you need it to be, when you need it to be, and correct and complete. You don't want to be making maintenance decisions on incorrect information. And we break down the railway asset model, what I call a digital parts list of the railway. And this is again from TS 50701. You can see that there's a surprising number of systems involved. And when you start to think to yourself, all of those have got software. All of those have got operating systems, just as you have apps on your phone and, like, your iOS, if you've got an Apple that gets updated. And all of them have hardware, sort of firmware, and that in itself is controlled by software. So how do you actually maintain them? How do you actually make sure that all of those systems are practical and connected and doing what you need them to do? And although your train comes out as digital from the factory gate, you are regularly needing to maintain software, move data and things like that. So I'm hopefully broadening your mental model to, like, the depth and complexity and connectedness of the digital systems in the railway and making the case for digital maintenance. So what does it look like? You're the maintenance tech. So this is from another standard around standard network design. As is the railway, we have a lovely, great big sort of soup of acronyms for the systems. Hopefully people can recognize PIS and CCTV and HVAC. You may be familiar with the term Ethernet. That's a type of network. And of course, you've got your passenger network. I'm sure we've all accessed passenger Wi-Fi. An MCG is a mobile communications gateway, which does what it says in the tin. But imagine that you're a maintenance tech and you need to update the software on there. You can see the things are connected, but what do you do? Where's the access point? Are you logging in via Wi-Fi to do it? Are you taking a USB stick? Remember those to do it. Or are you going up to the CCTV, unplugging the connection and plugging your maintenance laptop in, which then makes that maintenance network part of that train's communication network, part of its underlying digital infrastructure. So clearly, you have to be careful about what you plug in, the information you put in, and the information that you take back out again. And in my prep chat beforehand, someone said to me, what happens when you actually couple trains? And it is one of the most amazing things when you think about this digital infrastructure, that we couple trains and uncouple them on a regular basis. And each time you do that, you are connecting together two digital networks, and they are readdressing themselves, they're recalibrating themselves, and deciding, using that software on board and those protocols, how that information is going to get passed around, what you pass, what you don't, and how it's transmitted and stored. It is really quite mind-blowing. And it's something that you have in rail in terms of digital maintenance that you don't have with, say, a nuclear power station. Nuclear power stations aren't connecting themselves and unconnecting themselves on a regular basis, neither offshore oil and gas. But on the railways, that's what happened. So it adds that functionality, but it also adds vulnerability. And this is something to bear in mind. Maintenance is an ongoing activity to ensure performance and safety, whether it's a physical or digital system, but that inherent connectivity adds a vulnerability. And many of us aware that we are moving to onboard digital signaling through ETCS. On the right-hand side, we have a picture of conventional signaling system in the UK. And on the left-hand side, you have the ETCS deployment. And I've just highlighted the obvious thing, that there's a computer involved, and there's a flow of information, and there's a driver-machine interface. Now, clearly, these have been decided with standards in mind. These have not been just any which way connectivity of cables and boxes and software and systems. But even with the best will in the world and the most in-depth design, that then gets released into operations, and then you have to maintain. And that through life cycle view of how you look after that software so it does what you need it to do is why maintenance is so important from the perspective of us, a rail cybersecurity company. Now, I'm sure many of you are familiar of the problems that happened with software on rolling stock following some power variations. It was investigated by the UK regulator, and they produced a report which is well worth a read to understand what happens when software is not quite what you expect it to be and doesn't do quite what you need it to do to maintain the best available safe operations. And when you have to go and deploy a technician to each train with a laptop to be able to reset the software, it's no stretch of the imagination to imagine that that's got significant performance and operational impact. And that's why the ORR investigated in the general sense and released this report. So if you're going to read something, what happens when software goes wrong, have a look at this one. And I was Googling, as you do when you're looking for good graphics and preparing a talk, and I found this one here, where I wasn't aware of it, but there we are, software testing news, and they were saying software issues delay the reopening of a certain line. So taking that view of digital systems, not just, oh, cybersecurity, oh, it's a malicious actor trying to hack into my train, but a holistic view is so important. So now let's look at some of the practicalities of digital maintenance, because this is very much for all of us on the railway a work in progress, because as we increase the digital performance of the trains and the capabilities for obvious reasons to build passenger confidence, to increase freight, to increase functionality, we also have to learn what it means in practice to do that maintenance under the increasingly tough commercial conditions that we all find ourselves in today. So it's a challenge. A little calibration point here. Imagine if you have a train unit, and then you count up how many of those connected devices would you have in an average unit, and you can assume 100. And this is something that is not wildly out of step with reality. And actually, the talk I was doing for the Safety and Reliability Society a couple of days ago with digital incident investigation, and I was speaking with RAIB and Network Rail, and we were looking at Cambrian and Broadly, and the Network Rail speaker said, you know, in preparation for this talk, I went around my house and I counted up the number of connected devices. And he said, I've got a relatively small house and I've got 3 children. He said, I found 100 devices. Now, when you multiply out what that means over a mid-size operator, how many of those operating systems, Windows or other, how many of those switches controlling that flow of information, and how many of those access points, it's quite extraordinary. So digital maintenance, you really do need to sort of start to peel back and think what it means for overall operations. At this point, possibly people who aren't working in maintenance or operations or only in the physical side are probably going, oh, this is the big scale of a challenge. And that's what it is on a daily basis. Now, what we find and what we hear, and I'm looking forward to hearing people's views, what they do in practice, is that it's normally a human that's involved, a manual process, you know, typically someone with a laptop or USB stick. And the other key feature is that immediately you're not spotting whether something's not quite right, an adverse condition. When you go and open the door and look at like a digital panel and a cable, and you plug it in and you do something, you don't get the great big alerts. There aren't firewalls or virus warning systems or any of the things you might find in your normal sort of personal laptop. And so it is possible for a train to be released into service with wrong and not fit for purpose for software. Now, that could be the right software installed in the wrong way. It could be the wrong version of the software. Lots of different ways in which that wrong can be seen, but things are just realized in performance problems. Now, there's a couple of sort of terms I want to highlight here: vulnerability and threat. Now, a vulnerability is that weakness that I'm talking about. And it could be procedures, it could be controls, it could be implementation, or just the overall system architecture. And we're not in a perfect world. We can't do secure by design. But that weakness in itself doesn't cause a problem unless it starts to meet a threat, which is, you might immediately think of nation state actors, cybersecurity threat, but put more softly and gently, it's any situation or method that might accidentally trigger. And of course, you do have the potential for people choosing to do the wrong thing. And that could be an insider, someone that's disgruntled and wants to, it doesn't happen very often, fortunately, but there's always a possibility for someone choosing to do something wrong for whatever reason. And the same goes for organizations choosing to do something wrong. And this is the unfortunate world that we find ourselves. So never look to sort of blame the person as to why it happened, because with all of this complexity or unclear software procedures or problems with time pressures, it's possible that processes are not followed. So you can see here easily enough, and I've given some examples of broad software issues, performance problem. And when you have performance, then you have the possibility for a safety impact. It could be direct impact because that safety of that system isn't doing what you need it to, but also when you have a PIS system or a CCTV that's not working, there's also that knock-on effect, that broader operational performance, that broader safety impact, which is why it's so important not just to look at like the safety critical braking system, but the whole system overall. Unfortunately, and I would prefer not to be giving the talk in this situation, the current practices do represent a significant source of risk, whether you look at it from the safety perspective or cybersecurity. And one of the key things and themes in this talk is you're finding that like we are a rail cybersecurity company, but I'm using words like safety and performance and maintenance as much as I am using the word cyber, because when you look at it overall, the label is less important than the activity or the action. Putting a USB stick in or an out-of-date laptop, and people are having to use old laptops with old operating systems because of the old software, I should say mature software here, that's in place. And you've heard about it with other power stations or nuclear power stations and so on. Sometimes people are still running Windows XP, if you can remember that. And when you have that one person going around connecting and unconnecting and with manual steps, it costs time and it costs money. And any opportunities for improving that, we should be looking to take advantage of. And when you have humans in the loop, and when you have complexity, and when you have the sheer sort of difficulty of the fact that you can't press a button and upgrade your trains fleet in one go, then you've got the possibility of out of synchronization. With the ORR and report, it's interesting that actually the more old software version actually had fewer impacts because the train driver could turn it on and off. And the newer installation that was on like a certain proportion of the fleet, he couldn't do that, they couldn't do that, which meant the technician had to come out with a laptop. So, and also when you're faced with a problem, if you're not actually able to find out what that previous update was, if there's no digital maintenance log of digital activities, then you're left with what actually happened. So the auditability, the traceability of actions is also a quality and performance problems. You need to have good situational awareness. And I've made the message, and it's just worth re-stressing it, that the tools of the trade that people use, these service laptops, is key. And just as like your work laptop or your home laptop can have some problems with malware or spyware, or the laptop accidentally becomes part of the train network, this is something that people, the potential to experience on a day-to-day basis, and you may not know it's happening. So unsurprisingly, given that we look at the network and the vulnerabilities, we've got our thinking caps on. And what we're working on right now, and this is one of the solutions putting in front of you, is how can you actually improve that local maintenance? Because you can't take all the existing laptops and no, we're going to all move to the latest version of the laptop, because you have to work with the digital infrastructure you've got. You can't say, right, you're not going to plug in, because then how do you update? So we have a security gateway, and what we're developing is an onboard virtual service laptop. And what it means is that you can keep going with the existing systems, but when that laptop connects in, it connects into a certain point. It's not just anywhere in. You control what that software can access, you know, both the person and the software activity. Because if the software can't run, or the person can't log into that particular software, think of those 100 systems, then they can't do anything. It's called admin control and access control. And also you can keep a track of the changes. So that's the first step towards improving local maintenance. So using a cybersecurity hardware and system and installing this virtual service laptop functionality on board. And we're in developing that and trialing it with some of our clients. And it's underpinning the way that we're thinking about our whole system development. Because cybersecurity is no good if it's just a separate function looked after by one person. It needs to be integrated into the whole flow of the railway network. So what's the next level? Remote access. Dialing into your train remotely, again with like the careful checks and balances that not anybody can dial in, and then also once they connect in, then are they the right person? Are they doing the right thing? And you've got that privileged access management. And that then sort of moves us beyond the need from a technician to go train to train. There is an opportunity for improving performance. And then further, and this is something not yet in place, maintenance automation. So you don't have to put that human in the loop making those active commands, but we are not yet at that position now. But that's something that we are actively thinking about as a priority. And there we are. What would a talk be from us without actually an example of here's one we made earlier, here's one we're developing. And there we are, a box that you plug in into your train network, into the service laptop can connect in, and then you've got the maintenance applications. IDS is intrusion detection. I'll cover that a little bit more. And the authentication, you know, are we happy with this digital maintenance activity that's going to carry on? Are we happy with the person that's logged in? And so that's what it looks like in practice. So to the management frameworks, because we work in a highly regulated industry, it is very important for us to look at cybersecurity in context. It's not just the responsibility of the person with cyber in their job title. Just as safety isn't just the responsibility of someone as the head of safety. And the regulator, and like, you know, anybody really that looks at the overall system, they want to know how are you operating your overall system so that it does what you want it to do. Now, possibly a message to pop out from here. because people think of cybersecurity, they think IT cybersecurity, and perhaps a smaller community of people think cybersecurity of trains, yeah, OT, if you like. And this picture is again from TS 50701, that technical specification on rail cybersecurity, which I encourage people to read because it gives that overall view. But the fact is, just as you have with that maintenance laptop, even though the systems you put in place, the standards that you follow, so we're ISO 27-2001 certified, and the type of equipment, the two work in, I was going to say in harmony, perhaps harmony is the wrong word, the two work together to manage the overall train system. So one thing to take away is that don't think of one or the other, think of both. Another thing, and this is something that was the core theme of my last talk for IOSH, was to use the management frameworks and to not consider the cybersecurity framework, the donut-shaped thing with the colors there, that's the NIST cybersecurity framework model, but not to consider it as separate and distinct from the Plan, Do, Check, Act, which underpins all of our operation in one form or another. We call it Plan, Do, Check, Act in the UK. I'm pretty certain that the same principles are used in many other countries and for many other railway systems. And I mentioned RM3, which is the ORR, Risk Management Maturity Model. And that points clearly to all the things that you need to do. And if you want to know what should I be looking at for the cybersecurity, I don't know where to start. You look at like the NIST cybersecurity framework. If in the UK, you can also look at the National Cybersecurity Centre, NCSC, you can look at their CAF, their Cybersecurity Assessment Framework. Key message here, and this is more and more relevant for the digital side of things, is don't just wait for things to go wrong. You really need to focus on those near misses or incidents because they give you the underlying root cause and trends. And because the line isn't very clearly drawn for digital maintenance through to digital incidents, and there's lots of different ways in which you can get to situations where then you get that vulnerability and that threat, looking at the things which are very much just sort of ongoing monitoring is essential. So here we've got an extract from the key points from the ORR Risk Management Maturity Model. Many people on this talk are probably going, yep, you know, I'm responsible for part of that. I recognize our overall safety management system. We do everything from, you know, worker, you know, competency management systems to culture to overall governance. But I've just picked out the bottom two and highlighted in the red boxes the things which are of particular importance, that require particular focus, that you should pick up your safety management system and ask yourself, my suggestion is, how are digital assets looked at in there? How are we managing those assets? Because as you can see, the criteria cover management of assets, they cover change management, and they cover control of contractors and suppliers. And the digital supply chain is very complex. This is something that Ray picked up in the Cambrian ERTMS report. And when you think about those 100 devices, and you think about the number of times you have to update your operating system on your phone or your computer or update the apps, change management as a part of digital maintenance is essential. And this is why this security gateway to protect and this virtual service laptop to track what you're doing is so key. And of course, management of digital assets. Could you take a pen and paper now and write down the number of digital parts, as I call them, that you have on your train? Could you describe the version number of the software or the operating system when it was last updated, or the firmware, the code underneath the bonnet that makes the whole thing work? So you can see that asset management is essential, but also those proactive monitoring arrangements, naturally audit, and unfortunately, should something happen, considering the investigation. So what are the priorities? There's a lot to absorb here. And so hopefully I've highlighted a couple of starter for 10 points that you can choose to start broadening your view of digital maintenance. And how are things going to realize towards the end of 2021 and 2022? And I would say that a key thing here is around incident response. We have here just a flow chart. It's just a representation example. We work with subsystem manufacturers, that's the bottom line. We work with train builders and maintainers, that's the orange line there. We work with Roscoe's, the owners, the blue line. And we, of course, we work with the operators at the top. And when we get an alert in from one of our systems, say the security gateway or the software within it, we have to decide, is there a problem or not? And at the moment, we're looking at it from cybersecurity perspective in many cases, but there's also the maintenance and there's the operations, there's the performance and the safety. And you have to pick up the phone, so to speak, to the train builders and maintainers and the subsystem, because they know the technical specifications. And ideally, you look to raise an operational ticket with the operator because you don't quite know what's happening at that point there. Then you decide further investigation. Then you need to have another go around. Then you need an incident report. And then you follow it all the way up. And clearly the ROSCO is going to say, do I need to do something here at this point? And clearly the operator is going to have to decide, do I need to make a report to an authority, whether it's the DFT or the ORR, and of course there's a possibility for an investigation too by RAIB. And then you have to fix the problem, remediation. And it's not like just swapping something out here and there. When you have to look at multiple deployments and updates, there is an ongoing incident response. And at the core of this, you need that maintenance data, that asset management, and that what I call storyline, that you're able to step back in time to see what was done last week, 2 weeks, 3 weeks ago, and also where you are with your fleet. Because at the moment, you can't just click your fingers and update everything simultaneously and be confident that there's not going to be any problems at all. Getting that sense of complete confidence is hard. So this is what drives us, what we focus on. This is just something from our website that, these are the things that we do because we do them because they're needed, whether it's monitoring or protection or ensuring that, like, through our systems, that the two parts of the network are separated, because you don't want to be sharing information when you don't have to. System logs, maintenance practice, and unfortunately, when something goes wrong, how to recover quickly. So just a couple of minutes over here, just some closing thoughts on digital maintenance. Hopefully I'm leaving you with the good sense that the railway is digital and it gives great benefits. And this digital maintenance perspective for performance and for safety is an integral part. And we really need to sort of lean into that in order to be able to sort of tap into what digitalization can provide for the railway, whether it's increasing capacity, improving the passenger journey, enhancing the type and freight that we can carry, and like the onboard signaling systems, and of course, supporting safety, because we do not want to learn from things going wrong. Now, the logging and monitoring is absolutely key, because if you don't know, you can't fix it. Now, people often say, well, of course, if you do the systems engineering and you consider right at the upfront of the design stage, you could consider a system that's secure by design, and you could actually put in these self-check mechanisms. But we're not in that theoretical world, we're in that real world. And particularly for digital systems, even though you will consider at the design stage what you need to do, you can't turn back time to design. You're already making the fixes during operations and maintenance. And so this is it. We have a complex railway, we're responding to developments, and we are doing the best we can, working with people across the railway to increase digital maintenance. And I think people, if they take their management health and safety at work regs hierarchy of controls, we are putting in admin and engineering controls, the barriers for processes, equipment, hardware and software, and of course people too. But of course, you should always look to isolate the hazard, substitute the hazard, or eliminate the hazard. So I'm very grateful to IOSH for giving RazorSecure and myself the opportunity to talk about digital and cyber to a broader audience. This is just part of what we do. We want to work with the industry to get the word out there and encourage the dialogue so we can ensure that people have the systems that they need. We've got on our own YouTube channel, along with subtitles, we've got the first part of a TS 507 on webinar, and there'll be more coming soon later. We were doing with RAIB and Network Rail, identifying, recording, investigating digital incidents. I talked to the next generation engineers, that's a young railway professional. I've never had such a trendy graphic in my life for a talk. And then last but not least, with IOSH. And I look forward to the opportunity to talk some more in 2022 and to continue the discussion on safety, cybersecurity, maintenance and performance. Thank you very much.
Thank you very much, Emma. It was interesting that I only got my education into cybersecurity from yourself earlier this year, and how I'm learning about it has been really interesting. whereas my colleague is into this all the time. But what really struck me is one of your first slides where you were talking about the secure network and the wall. And inside that wall, I noticed discreetly away was a track worker. And that track worker who would be relying on digital safety. This week, we've been discussing Margam and the incidence of track workers. And it probably may never have linked to many people. And it was only when I noticed inside that wall that we want to get people away from flags and warning systems, and we want to get people onto safer ways of working. But that just really struck me then about the track worker being reliant on the digital safety, security. And that really struck me when I saw that inside that wall, the impact if we don't get it right, that we may, potentially put people at risk if we don't follow all the procedures and the guidance. So thank you very much. I'd like now to hand over to my colleague Russell Keir, who will be looking at questions and got some, I noticed 1 or 2 questions coming up before we conclude the presentation. Emma, thank you once again, and I look forward to joining you in more presentations with IOSH.
Thank you very much.
Hello, everybody. I'd like to kind of tell everybody that there's no such thing as a stupid question here, because quite surely I'll have a few to put forward, and so I'll do that in due time. So we've got our first question from, and I apologise if I don't pronounce your name correctly, Ismaila. And what we want to know, this particular webinar is holistically, how can we compare and contrast health and safety and environment with cyberspace security and the railway?
That is an excellent question. And I think that from the point of view, my personal point of view, because I'm a safety engineer by training, relatively recent to cybersecurity, to compare and contrast, start with the management frameworks and have a look. And you'll be surprised about how much similarity there is, both in the overall sort of approach to risk identification and management, like BS, 3100031,000, the fundamentals of risk management. And also if you look at 9001, general management systems, and then line it up with, for example, the things that I showed, whether it's 27K, which is IT cybersecurity, or the TS 50701, there is a surprising amount in common. So that gives you perhaps confidence and also an existing mental framework, as well as a management framework into which to look for the differences. Now, speaking just like, sort of off the cuff, what are the key differences that struck me as I broadened my sort of knowledge of safety to include digital safety? And the driver for doing that was I realized that I would become an ever less good safety engineer until I got to grips with it and took part and worked with the people like at RazorSecure who are really sort of pushing things forward. And the things that struck me are the sheer complexity, just the number of systems, and unfortunately the lack of industry-wide awareness of the fact that this situation existed. And then the rate of change, both in terms of the external vulnerabilities and external threats, and also the deployment of digitalization. But the rate of change, the number of times you needed to change something in order to make sure that like you were safe as possible or meeting the performance systems. When you look at classic safety, the sort of trending and monitoring that's done by organizations such as RSSB, you can release the report. You can look at things on a quarterly basis. You can look at things over like quarterly or year trends, for example, with earthworks. Can you do that in terms of the rate of change with cybersecurity? I don't think so. And this is why there is this enhanced focus on protection and always being ready, because unlike with safety, what happened a week ago or a month ago might give you an indication of what might happen next. With cybersecurity, it's a lot harder to do that. So I think that in terms of compare and contrast, that will be the 2 or 3 first bits of advice I would have.
Ed, I think this is a follow-on from your own question about safe workers. We've got a question from Leslie, or a statement. I was wondering, as we in the industry move away from paper copy of an SWP into an electronic world of the same SWP pack via tablet devices.
I think, could I just mention this, Emma, this was a sort of been quite a topical subject from the RAIB workshop and earlier on in our presentations when, safe work packs to me are potentially can be anything but safe because of the sheer volume. And there's talk of putting them into an electronic format to make that available more instantly. Unfortunately, we still hadn't managed to get it down to a level that could actually be read on an electronic format, because if it was still 1,000 pages, it wouldn't be very safe. So I think it's very similar to the question what I was mentioning on track workers, I think, is that having the electronic information.
I mean, the electronic information point, and I used to work at RSSB, so I saw the importance, the deep importance, and the focus people are putting on protecting track workers. But I'm obviously speaking here on a personal basis. Electronic information has benefits. If we assume that the electronic information will be transmitted in a form without any potential for issues, and obviously like the scope of my talk highlighted how that could happen, you're still faced with a volume of information and tasks that you need to do based on that information, which you have to absorb in a digital form. And that in itself is a different kind of barrier to absorbing it than it does on paper. When you read something on screen, or whether you read something holding in your hand, we've all seen, particularly during this pandemic world, things stick in different ways, and that's human nature. That's human factors. There's also the need, and this is a deep challenge, how do you avoid flooding people with information? In cybersecurity, the principle really is only pass on the information when you must do, and only pass it on to the people or the systems that you need to minimize. And I can't comment on the work and the discussions that were held with the RAIB workshop, but it's the less that you have to read, the less you have to move, the less you have to handle. Surely you reduce the possibility for things not being as you need them to be, and then the knock-on possibility for things not working as you want them to. So it's not an easy answer, but with cybersecurity, for our monitoring and logging and auditing, less is quite often more.
I see that Leslie's refined the question a little, because apparently the wrong button was pressed. It really is considering cybersecurity on this overall process change. So I think the question is, as we move to digitalisation for the track workers, and they maybe arrange their possessions, their isolations using tablets and whatnot, and that's really with the infrastructure side of things. What's your thoughts on that?
It's a little outside of our sort of scope of responsibility here. So having worked across the railway and worked in a number of different roles within RSSB, I can see why people are asking that question. I can see the importance of it being discussed and agreed with all the stakeholders around the table. It strikes me as I'm thinking about it now that like one of the stakeholders needs to be the specialist providers of technical equipment, whatever shape that technical equipment is, who generate that information and need that information. So the people that produce the signaling systems that generate that information, need the updates, the people that produce the digital systems used to handle the information, and also the people that put the systems in place to protect the handling of that information, such as us. But let's not also forget the fact that the information is not only transferred by cable, but also transferred Wi-Fi, and is also stored sometimes in the cloud. So when you're setting the system boundaries of the people, organizations, processes, and stuff, hardware and software that are involved in that track worker safety maintenance stuff, make sure you set your boundaries broad enough. That will be my one key message. Make sure you're not missing out key people at the table.
Okay, a question from myself. You talked about auditability and traceability. What's your thoughts on reversibility if it goes wrong, going back to a previous version?
Are you referring to the significance test by chance?
Maybe.
Okay, right. Okay, so people may wish to have a look at the ORR criteria for what constitutes a significant change through the significance test, and what that means in terms of what you need to do under the CSMs. But reversibility with a small r, so not reversibility in terms of the significance test, is a real challenge. I mean, when you think about dialing back to a previous software installation, if you wanted to do it on like your phone or your laptop, think of the challenges involved. And also when you're making that change, are you sure you're making the change back to the exact previous same version? So quite a deep control, a version control of not only what the version is, when it was deployed, how it was deployed, what were the commands you did, but also what the software was itself is essential. Without it, you really can't be confident in that reversibility. And I think I wouldn't be going too far to say that, like, when you take a physical part, you put it in, you take the old one out, it might be easier to reverse that than the digital part in and out. I think I'm on safe ground saying that one's a bit more complicated than the other.
We spoke a wee bit more about the digital couplers. I'm just taking the opportunity to maybe give you an opportunity to talk a bit more on that. And I'd encourage somebody else to ask a question, because I'm making these up, you know.
Questions are good, but excellent questions. I must make sure we've got enough time for like our poor closing panelist, the wrap up of the conference too. So I think we mean quick wave to the man on the train. I think that the complexity, the fact that trains are becoming rolling data centers. I mean, they may not have the most modern software on board, you know, they may have out-of-date operating systems for obvious reasons, because they're hard to update. We may have older versions of laptops being used. But when you actually, our chief technology officer loves this. I think it's one of the best bits about his job. His face lights up when he talks about the fact you've got these two computer networks, okay, two train units, and you couple them and you readdress them. How does that combined system work well when you then sort of set off with, like, you know, the two coupled units? How can you be sure that the information from like the back unit on the braking software, the information is being transmitted clearly all the way up to the top, that the driver is seeing the right alerts on their HMI? It's something which I can safely say that I have heard people saying this is a bit hard. I think I'd safely say that people have had some operational challenges, you know, at the maintenance level, because, you know, you can't get these things right perfectly. So yes, digital coupling, you know, plugging two things together and them reconfiguring themselves, there's always the potential for some hiccups and challenges, and it's something that needs to be factored in to the design and planned for in the maintenance.
Edward, do you want to come in and say anything at this point?
Yes, I think you've just introduced another webinar with the coupling. So I think that's something that we can take forward. And as Emma said, now we can conclude by, if you can introduce our past president. And thanks once again to Emma. I think we've got a new webinar on the horizon.
Thank you very much.
Thank you.
Thank you very much. I don't know actually very much about James Quinn. He's been around for quite a long time. He's done an awful lot of good work in IOSH. He's a very experienced health and safety expert. He may come from Scotland. I don't know if he does or not, but I think his accent might give it away. But I'm sure James will come in, or Jimmy, as I think he's preferred to be known, and to sweep up on what we've done this week. Thank you, Jimmy, if you're there. We might have lost him on the train. Ed, do you want to pretend to be Jimmy while he's lost?
Yeah, I think I could, just probably without the accent. No, as we can see that Jimmy's the past president of IOSH. He's only just handed over, literally in the last week. Jimmy has done quite a lot with IOSH in the last couple of years, and he's certainly supported the railway group in everything we've been doing in the last year. And Jimmy was going to just come and tell you about IOSH and also cover on the work we've done this week on this webinar, where we started with the Great British Railways and safe systems of work and sustainability that needs to come through with the RSSB, who are monitoring that for us when the white paper hopefully becomes law. But then we return this week to Nick Millington, who came to us a year ago, just after the RAIB report into Margam was published. And it made a very, well, I wouldn't say uncomfortable, but it wasn't the easiest presentation with that report and all the recommendations that came out of it. But when Nick came back to us this week and demonstrated how much work the Track Alliance had done, Safety Track Alliance work had done in that year, it was really quite impressive. And we were really pleased as a safety professional body to see such developments in such a short time. So it really was quite an impressive development. And then we had, unsurprisingly, Louise talking about COVID and a new way of working. And it really is, you know, I was in my office listening to it for the first time in 2 years. So we really had a true reflection on how COVID has affected the rail industry. Who would have thought that you would be getting your meals on the train through an app and go into the buffet and asking what you want to eat and then being delivered to you? One of the simplest measures of changing how we work. Jimmy's just back with us, I think, and if I can hand over to you, Jimmy, if you're available.
I'd just like to thank Ed for recovering, because I did throw him under a bus there. Anyway, James.
Yeah, you're on mute, Jimmy.
Can you hear me?
You hear me now? Yeah.
Good. Okay, here we go. This is crazy, being on a train today. I'll probably duck in and out, and I hope not. But let's go with the closing of this amazing conference today. So, good morning, good evening, good afternoon, wherever you are in the world today. And as befitting the IOSH International Railway Group Conference, I'm indeed on a train heading into London, as of course my other train was delayed with leaves on the track. Fate, perhaps. My name is Jimmy Quinn, and I am the immediate past president of IOSH, and it's a pleasure to close this amazing conference. I'm sitting in first class at the moment, so hopefully the noise won't be too amazing. I'm not a first class ticket holder usually, but the guard gave me permission to sit in here today as well. We have some excellent speakers and great attendance over the last 3 days. We heard from Mark Phillips, the CEO, and Ali Chengini, of the Director of Systems Safety and Health, on health and safety and sustainability, and how plans for the new and Great British Railways will be developed with safety in mind and with the oversight of the RSSB. Nick Millington gave the Safety Task Force Director at Network Rail returned to update us on the safety improvements promised after the Margaret fatalities. I think we can say that he and his team have delivered. A detailed presentation on the develops taken to improve track safety was evident, even if there is more to be done. IOSH, is the world's largest safety organisation, acknowledges the work and progress Nick and his team have achieved. From Hong Kong, former IOSH president and fantastic colleague, Professor Vincent Ho, and Alex Lau, our first international member of the IOSH Railway Group Committee, provided us with an international perspective on how intelligent safety is being used for staff and passenger safety on the Hong Kong Mass Transit Railway. European Safety and Sustainability Director Louise Ward reflected on a subject close to all of us, on how railway employees have adapted in circumstances never imagined 2 years ago, in learning lessons from our COVID experience in the rail industry. And last, but certainly not least, Dr. Emma Taylor from RazorSecure provided us with even more clarity, looking at improvements through cybersecurity and a route to building passenger and operator confidence. Finally, on behalf of IOSH, the amazing Ed Hodson, and the IOSH International Railway Group Committee, I would like to thank all our speakers and all of you for attending and supporting our conference. Until then, stay safe, stay well, and above all, please continue to be kind. Thank you. Back to you, Ed. Russell.
I think that demonstrates that we actually live and breathe railways in the railway group. This is what we do. And all things going well, the leaf fall season in the UK is going to pass pretty soon.
I mean, it's really, really difficult for me to hear, Russell, but I got some of your thanks there and some of the words. But isn't it amazing to be sitting on a train today, heading into London? And the journey's been absolutely fantastic, to be fair. After the incident that happened in Salisbury a few weeks ago, the rail is now open, and how difficult it was to travel when that line was closed down as well. So a really important line to be open. And thank you very much, Ed, for allowing me to close this fantastic conference. And thanks for your sterling work navigating it today as well, Russ.
No worries.
Thank you very much.
By the magic of working at home, a cup of coffee has arrived with me.
Thank you, everybody, and have a good journey, and hope to see you next year. Thanks a lot.
Thank you. Goodbye.
Bye.
Take care, everyone. Bye-bye.